Guys, Mr. G here with another video for the grade 12 related to chemistry. In this video we are going to be learning about homologous series and functional group. Last time we already spoke about hydrocarbons, and there are three of the different homologous series, but we are going to go there just now. We learn about hydrocarbon, how to classify hydrocarbon into saturated and unsaturated. We know that the saturated have only single bond between carbon, and the saturated can have either double or triple bond. The single bond compounds are going to be called alkanes, the double bonds alkenes, and the triple bond alkynes. And we're going to be now talking about homologous series and functional group. And let's therefore start writing the definition of homologous series here. Alright, so what is the definition of homologous series? It is a series of organic compounds that can be described by the same general formula. I think of a homologous series like the different families. So when I think of homologous series, I think of a family, and those families are going to be named just now. Now, what is going to be the functional group? Functional group is a bond or an atom or a group of atoms that determine the physical and chemical properties of the group of organic compound. In other words, we're talking about the homologous series. So when I see functional group, what I picture is the characteristics. When I look at functional group, I'm thinking of a characteristic, that thing that can help us to identify the different families. So the functional group here will help us to identify the families. So this functional group is the one that is going to help us to determine, to identify what is the family or the homologous series, okay? So they are very interrelated one to another. The functional group is that characteristic that you tell, okay, this is this specific family. For example, if we go here, we can see that this one have a specific characteristic, which is the double bond. This one would be the functional group, and the family then it will be the alkenes. So we have now the homologous series is the alkene, in other words the families. And how do we identify that family? By looking at this characteristic, which is not other thing than the double bond between carbon. We're going to name and mention and explain each of the different homologous series which with its characteristic of functional groups. And the first homologous series we are going to mention, we're going to start by the first one, which is alkanes. And we already spoke about alkanes. Now, alkane has the characteristic that all the atoms that is going to be involved is only carbon and hydrogen. Only carbon and hydrogen, and they are going to only be single bond between carbons. For example, like this one is the functional group. Only single bonds between carbons, as you can see here. So it doesn't matter how long or how big is the compound, is only going to have single bond between carbon atom. And something important we must mention, there is something called a general formula. The general formula for alkane is going to be CnH2n plus 2, which means all the alkanes will follow these trends, and we can use this formula to identify if certain compound is an alkane. Let's use one simple example here of an alkane, and it will be, for example, propane. Later on you will learn about naming. This one here is propane. You can see that all the bonding between carbon is single bonding, and you can see that only have carbon and hydrogen. Okay, so this is the first homologous series, and the most important things here about that homologous series, which we are going to follow this trend for each of them. The second homologous series is going to be the alkenes. alkenes. What is the characteristic of alkene? Is only carbon and hydrogen. Okay, and so how do we identify the alkenes? Well, the alkenes will have, remember, only carbon and hydrogen, but you will see a double bond between carbon, at least one double bond. We already spoke about alkenes just now. All right, if there will be a double bond between carbons. What is the general formula for alkenes? Well, all the alkenes will follow CnH2n. This is the general formula for alkenes. So all the alkenes will follow that general formula. If we go to one example, and let's use the same example as before, remember we have the propane. We are going to have here also 3 carbons, let's say 1, 2 and 3 carbon, but there must be a double bond, and you make sure you have 4 bonds for each carbon. So the first carbon have 2 bonds, 3 and 4. The second carbon has 1, 2, 3 with the other carbon and 1 with 1 hydrogen, and then the last one has 4. So all these ones are hydrogen. This one is an alkene. In this case, it's called propene. Okay, propene. But we later on will learn about the naming. But let's write it just here. This is propene. Okay, so this is the second homology series we are going to do. Let's go to the third one and follow, as we said, the same trend. Now, the next one we're going to do is the alkynes. Now, the alkynes is, as we said previously, is only carbon and hydrogen. Only carbon and hydrogen. It is another hydrocarbon that we already learned previously there. Okay, it's only carbon and hydrogen. And the functional group, or how are we going to identify this alkyne, is with a triple bond between carbons. So it will have at least one triple bond between carbon, and only carbon and hydrogens. Okay, so here that is important. What is the general formula for the alkynes? For the alkynes, the general formula will be CnH2n minus 2. This is the general formula for alkyne. Okay, and then if we go to one example here, we have, let's go to use the same one, carbon, triple bond with another carbon, and then another carbon. This one is going to be propane, and then we count. The first carbon have 3 bonding with carbon and then 1 more bond. The second carbon have 3 bonds with the first carbon and 1 with the second, so it's already full. And the last one, we have to add the hydrogens to make 4 carbon. There we go. There we go. Okay, so that is how it works. Okay, that is the alkyne. This is one example, and this is propane. Propane. Okay, note that this will end in -ine. Okay, if you go to the alkenes, they will end in -in. If you go to the alkanes, they will end in -n. I didn't write the name for that one there. Okay, so this is the first 3 functional or homology series we learn in here. Now, the next homology series is going to be the haloalkane or alkyl halide. Okay, this one is going to be the haloalkane, or also called alkyl halide. Now, alkyl halides, the functional group or how do you identify the haloalkane is because it's going to have halogens. Going to have halogens in the bonded to the main chain of carbon atoms here. Remember, halogens is a group 17 in the periodic table. Group 17, say for instance chlorine, fluorine, bromine, iodine. Those are the ones I'm talking about here. And then the functional group will be, or you will identify, because to the carbon there will be hydrogens, but they will be bonded somehow a halogen. We're going to call this one X, and that X is going to be a halogen. It must be one of the halogens. Okay, so how do we get the general formula for this one? The general formula for the halogen will be Cn H2n plus 1x, plus 1x. Let's just write x plus 1x, where x, remember, x is going to be any of the halogens. So let's use one example to follow the same trend we use in here, and we use the example with the 3 carbon. Okay, example with the 3 carbon, 1, 2 and 3 carbon. Now in the first carbon, instead of everything being hydrogen, I'm going to add a Br, for example, and then the rest are hydrogen. But it could be more than one Br, it could be more than one Br, it could be one Br and one F. It doesn't really matter there. Okay, now the name of this one, but remember, you're going to learn naming later on, is 1-bromo-propane. 1-bromo-propane. That is the name for that one. And look here, how do you know it is a haloalkane? Because there is a halogen in the first carbon, or it could be in any of the carbon, but in this case is in the first carbon. As long as there is one halogen and it's only carbon and hydrogen, there is a haloalkane. Remember, halogens can also be bonded to any of the other homologous series we're going to do later on. Okay, so now let's go to the next homologous series here. The next homologous series is going to be the alcohols. Okay, now how do you identify the alcohol? What is going to be the functional group for the alcohol? Well, you will have an OH connected to one carbon. There must be OH. It must be connected to one carbon there. This OH is called hydroxide group. This one is called hydroxide. That is called hydroxide, and it's going to be connected to one carbon. Okay, the general formula will be just CnH2n plus OH. So it must be one OH there in the chain. Okay, so this is the alcohol. And if we go to one example, let's go to see the example to follow the same trend. The example with 3 carbon is the same example we've been using up until now. The carbons must be just connected to each other with single bonds normally as usual, but now there must be at least one OH connected there. So this now could be an alcohol. In actual fact, this here is an alcohol. Later on you will learn more about alcohols, like a different type of alcohol and so on, but you can see here that one OH is connected there to these specific alcohols, and the name of this one will be propan 1 or 1-propanol, but we are going to learn just naming later on. Okay, so this is the functional group of the homologous series of the alcohol. Let's go to the next one. The next one is going to be called aldehydes. Remember, those are the families. Don't place it so close to the corner there. Aldehydes, those are, remember, note here that this one will end in ol. The alcohol, the name will finish in ol, as you can see in this side here. Okay, so now aldehyde is going to be just the homologous series and the functional group. How you are going to find the aldehyde? Well, there will be a carbon which must always be the first carbon connected to oxygen and hydrogen. This is the functional group of the aldehyde, and things starting now to get a little bit tricky here. That is the functional group of the aldehyde. Now note, this carbon that is connected to oxygen and hydrogen, it must be then the first carbon of the chain or the last one, which is the same. Okay, so this is important. The general formula for the aldehyde here is CnH2nO. That is the general formula for aldehyde, which means all the aldehyde will follow that general formula, and it has a name. This functional group has a name which is called formyl. Formyl is the name of that functional group. Okay, so here is the thing of aldehyde. Now let's see one example. I think this is very important because you see it. So we have 3 carbons, for example, because we've been using 3 carbons, so we're following the pattern of the same number of carbon here, guys. Now 3 carbons. Note, this functional group must be bonded to one of the carbon that is on the stream, so it must be either this one or this one. Then it does not really matter, but it cannot be in the middle. It must be always in one of the streams. So in this case, let's do it in the first one. There is the double bond O, there is the double bond hydrogen, and we keep the rest of the chain the same. So now count. The first carbon have 2 with oxygen, 1 with hydrogen, and then the rest is just hydrogens in the chain here. Okay, and the name of this compound is going to be propanal, and as you can see here, it will end in al. Alright, so guys, this is the aldehyde. It is a little bit more tricky than before, but not so much. It may be confused with alcohols if you're not looking carefully. Now we're going to see the next homologous series, which is going to be called a ketone. Now the ketones, the functional group is a carbon. This is, remember how to identify the family. It's a carbon that have a double bond with oxygen, but that carbon cannot be bonded to hydrogen like before, because if it's bonded to hydrogen, then it is in fact an aldehyde and not a ketone. Can you see that on the here is bonded to hydrogen, but this carbon cannot be bonded to hydrogen. It must be bonded to another carbon at least. That is the functional group of a ketone. If you can notice here something now interesting that is coming, the functional, the general formula is going to be the same as the aldehyde because they are almost the same. Okay, there is something we're going to learn later called isomers about ketones and aldehyde, and that is why they have the same general formula. In fact, they would have the same molecular formula. We're going to speak about that one later on. Let's see this example of the 3 carbon. So it will be 1, 2, and 3 carbon. This carbon in the middle is bonded to oxygen with double bond, okay, and then the other carbons are just finished with 4 bonding, in this case hydrogen. There we go. Now notice this is, we keep the 3 carbon. The name of this one will be propanon. You can see now can see now that it ends in on. This is here. A propanone, and each propanone is the smallest ketone they could be. Next homologous series, we almost done. We only have 2 more homologous series here, guys. The next homologous series is going to be the carboxylic acid, and now this one can also be confused with aldehyde very easy. In the last carbon, you will have one carbon that is double bonded to oxygen, but this one here won't be hydrogen. It must be another oxygen which is bonded to one hydrogen, and this one could be really confusing, guys. I hope it's not the case, but it could be confusing. Let's quickly change that color for the highlighting here. So it could be really confusing. What is the general formula for the carboxylic acid? It will be CnH2n O2. You can see you have 2 hydrogens, okay? And like before, this functional group must be only at the streams. You can see it here in that one, okay? And this functional group have a name which is called carboxyl, and that question is being asked all the time. Okay, this is called carboxyl. The name of that functional group is carboxyl. So let's see the example we've been using all the time. We have 3 carbons, and then the functional group note there. It must be one of the streams carbon as before. So let's do it at the last one this time. We have oxygen, you have oxygen, and you have hydrogen, and then the rest is just completing the bonding. Make sure you count, guys, 4 bonds for each carbon. It must has 4 bonds. Okay, cannot be less, cannot be more. And this one will be propanoic acid. Propanoic acid, and as you can see, it will end in oic acid here. This is one carboxylic acid. There is more, obvious. I'm just using the same example for each of them so you can see the same compound with a different homologous series or different functional groups. So let's go to the very last homologous series, but there will be a video just for this one. This one is esters. Now, the esters have a functional group of a carbon which is double bond to oxygen and a single bond to oxygen. Look here, like the carboxylic acid. But this one here cannot be bonded to hydrogen, because if it is bonded to hydrogen, then it's another carboxylic acid. So this one must be another carbon, guys. This one must be another carbon. So this one here is the functional group for the esters. As I said, we're going to have then later on a video just for esters, because esters could be very tricky. And the general formula will be the same as the carboxylic acid. The same happen like ketones and aldehyde with carboxylic acid and esters. It will happen the same as before. And now this one here, we can just complete with the 3 carbon, but the 3 carbon could be tricky because could be in different also. I'm going to give you one example, but it could be a different one. So I'm going to have the 3 carbons there, but in this case, remember there is an oxygen in between. So you have oxygen, you have carbon. This one is going to be the functional group here, and then I'm just going to add another carbon right here, and now it's the 3 carbons we had before. We use examples of 3 carbons all the time here. Okay, so the rest are hydrogens. And the functional group, you can see it here in this side here. This is the functional group for esters. Okay, remember the O must be bonded to a carbon. Now, the name for this one, that one is going to be ethyl methanoate. Ethyl methanoate, and later on we're going to learn about that, but the name will finish in O8. Later on we'll see name. Okay guys, so this is all the homology series we did. This is all the functional group, how to identify. There were the 2 definitions. When we begin, we went to general formulas. We see one example in each case, and I hope really help. I hope it helped. This could be quite tricky, guys, but thank you for watching. I'll see you next time. Thumb up, subscribe for the channel. Mr. G here.